Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have a function of two variables, x squared plus y squared plus 8x minus 12y minus 3. And we have to find any relative extrema and saddle points of this function. Now, you should think of how we should compute relative extrema and saddle point and what do we need to compute first. You should have a plan of how to start and then reach to our destination, you would call. Recall that to find relative extrema or saddle point, we first need to compute critical numbers. Now, what do we need to do to compute critical numbers? We need to compute the partial derivatives, right? The first partial derivatives. And then later, actually, we have to do a test, a second partial test to test for minima or maxima. So we also need second partial derivatives. So let's start. Let's say first we will find critical numbers. And keep in mind that we need the first partial derivatives to compute critical numbers. Okay. So let's start with fx, and that is the partial derivative with respect to x of the function. Note that this is with respect to x, so all the terms that has just y is a constant. Y will be considered constant. So all of these terms are constants. Okay. So the derivative of x squared is 2x, y squared is 0, derivative of 8x is plus 8, and then the rest are 0. So this is the first partial derivative with respect to x. Okay, let's also compute fy. So the partial derivative with respect to y of the function. All right, now remember x is constant, okay? So x squared will be constant, 8x is constant, and negative 3, okay? And so first term is 0, second term derivative is 2y, then 0 again, then negative 12 and 0 again. So we got our first partial derivatives. Now remember how to compute critical numbers? Critical numbers will be computed by setting each one equal to 0 and solving for whatever point we find. So let's do that. So fx0 gives you 2x plus 8 will be equal to 0, which means 2x is negative 8. So x is negative 8 divided by 2, so negative 4. Also, fy 0 means 2y minus 12 is 0. So 2y is equal to 12. So divide by 2 both sides. So y is 6. And therefore, we have our point negative 4, 6. That is a critical number. And that's the only one, because that's the only point we can get by setting the first partial derivatives equal to 0. So this is our only critical number. Okay, now the second step is to figure out what do we have at this point. Is it a minima, a maxima, or a saddle point? Okay, so that's part B. Okay, so this is where we will figure out whether it's a relative extrema or a saddle point. Now, how do we do that? Recall, we need to compute this value for this d, and d, the formula is, it is the second partial derivatives f(x(x) at the critical number times f(y(y) at this critical number minus f(xy) at the critical number -4, 6 square. This is our second partial test. So you compute the value, and looking at that value or the sign, we will be able to determine whether we have extrema or saddle point. Okay. Now, as you can see, we now need to compute the second partial derivatives. All right. So let's try to compute it right here. What is f(x(x)? Okay, fx is right here, right? We have to take the partial with respect to x. So this is partial with respect to x of 2x plus 8. And what is the value? Well, derivative of 2x is 2, derivative of 8 is 0. All right. Now what about f(y)(y)? That's the next one. So that is partial with respect to y of fy, which is 2y minus 12. Again, notice the derivative of 2y is just 2 and derivative of 12 is 0. Finally, fxy, that is partial with respect to y of fx, 2x plus 8. And since there is no y at all, the whole thing is constant, so the derivative is 0. Okay. Now let's go back to our d, and notice that all these values, the second partial derivatives, they're all constants. So whatever critical number you plug in, doesn't matter, you will always get that constant, right? So if we want to compute this quantity d, what is f(x(x) at -4, 6? See, f(x)(x) is always 2, so at that point it's still 2. What about f(y)(y) at this point? Again, it's always that constant, so it's again 2. Minus, we have fxy is always 0, so this is 0 square. So d is 4. That means d is positive, of course, and notice that f(x(x) at the point -4, 6 is equal to 2, and that's also positive. The second partial test says if d is positive and f(x(x) is positive, that means at that critical number, the function has a relative minima. So this means relative minima. At -4, 6. So we get a relative extrema. And since there is no other critical number, there is no question of having any saddle point at all. So no saddle points, but we get a relative extrema, and that is a relative minima. And that completes the problem. Thank you.